Hello everyone, my name is Lamakoni, an electrical engineering student at Central University of Technology, and I'm back with a more detailed video following a video where I introduced my proposed project. As I did mention, the project is a bicycle speedometer with a few add-ons to make it very efficient. This project will help our cyclist to know the speed at which he is moving at, as it will be displayed on the LCD screen. But to measure the speed, we have a magnetic reed switch to calculate the time taken to complete one cycle, and then use it to divide the circumference of the wheel in order to get our speed. As we all know, speed equals the distance over time. But also, an ultrasonic sensor has been added to warn the cyclist of any danger coming from behind. If the danger is within 75 centimeters from the bicycle, as gathered by the sensor, it will be displayed on the LCD screen and simultaneously turn on the buzzer and the red LED. But if not, the green LED will remain on and the buzzer off. Now, let's have a look at our block diagram that represents our system. The system is powered by a 5-volt supply which can be easily plugged into a power bank as the cyclist moves. We have two inputs, namely the ultrasonic sensor and the magnetic reed switch, to measure the distance of anything behind us and the speed of the bicycle, respectively. We also have our Arduino, which acts as a medium of communication between our inputs and outputs. We then have three outputs: the buzzer, the LCD display, and the RGB LED. This all act in accordance to the information fed by the inputs as mentioned in the project description. Let's now take a look at our flowchart. Once the system is on, we will check to see if the bicycle is moving. If not, we will do a retest. But if yes, the speed of the bicycle will be displayed on the LCD display, and also the distance of anything moving behind the bicycle. Moving on, we will also check to see if there is anything within a distance of 75 centimeters behind the bicycle. If not, the green LED will be turned on up until there is something within that distance. Then the red LED and the buzzer will be turned on. On the other hand, on the speed part, we will also check to see if one rotation has been completed within 5 seconds. If not, the speed will remain as 0 kilometers per hour. But if yes, the speed will be recorded and we will repeat the same procedure. Once everything has been done according to the code, we will then go back again to retest the same procedure in total to check if everything is working, or to check if the bicycle is moving. Thank you. Okay guys, now back to the project. As you can see here, this is our ultrasonic sensor, which, like I said in the previous section, will be put just right under the bicycle seat, facing the opposite direction. And here, this is your LCD LED, and just right here is your buzzer to notify you of everything that's happening around you. Remember that. We have here a makeshift wheel, which will be just our demonstration for our bicycle wheel. So now, back to what I was saying. speed will only be recorded here once the wheel starts moving. Now, once the wheel starts moving, there will be speed recorded. And once the bicycle stops moving or starts slowing down, also the speed here will slow down. Back to the ultrasonic sensor. Now the ultrasonic sensor, please remember carefully, I've given an allowance of 75 centimeters behind the bicycle. Now should anything come within that distance, the buzzer and the LED will go off, warning the cyclist of the danger behind him. But if there is nothing behind him, the LED will go back to green as it was when the system was turned on, and the buzzer will remain off as it was before there was danger behind him. Once again, folks, thank you for watching.